Modeling the Gateway Arch in St. Louis using Desmos, and we're doing the absolute mean error to analyze the accuracy of our model. Okay, so firstly I've got the photo uploaded. I've got it scaled so that the vertex is at 192. That's 192 meters. If you use feet, you're going to have different numbers, of course, but I use meters. And the height is approximately 192 meters. So that's the vertex. I could have scaled it a little bit better so it was a little bit closer, but this is what I've done. Okay, so I got the vertex labeled. Now, before I actually graph my model, I'm going to plot some points along the outside of the shape, and then I'll use those points later to compare to my quadratic model. So I'll show you what I mean. I'm going to type in some points that will pop up on the outline, 0, 0. Now I don't want to analyze just points on one side or one cluster. I want to kind of space them out, so I'm going to go up in 20s. So 20, if I look at the graph, 20 on the graph looks like about 90, maybe 90? Oops. Okay, maybe 90. Maybe I want to bring it up a little bit more. Maybe 91 is a bit better, so that the center of the circle is right on the outside, so maybe even 93. Okay, and then we'll go on to another one. 40 and 40 looks like about 145 maybe. Yeah, maybe, or 146. Okay, so you can keep doing that. The vertex is 96, so you're gonna go up to 60, and then 80. Then maybe we'll skip 100 because we already have 96 up there, so maybe I'll go to 120. Okay, so you're gonna fill in all those with points. I'll show you what the finished product looks like. So I've got a bunch of points on the outside. Okay, so make sure they're all lined up. So when you do your quadratic model, it should go through those points. When I did the model and I did some calculations to figure out what the A value is, I got an A value of negative 0.0208. So let's take a look at it. So I'm going to turn it on by clicking this button. And it does go through a couple of points, and it kind of misses some of these points here on the side, right? So you look at this black point here, it's missing by this amount. Okay, it's off of our model by quite a lot. Okay, but this green point is only off by a little bit, and this point here is off by a fair amount, and this is off by a little bit. So one way to analyze the accuracy of your model is to look at these differences between the points on the actual object and then on your model. So we're going to look at the difference of these y values. So I took all these points and I put them into Microsoft Excel. Okay, so these are the x values and the y values of the points. So these are the points that are plotted. Now we're going to compare those with the model. So I'm going to make a new column y of the model. And the model is negative, so to make an equation we type in equals negative 0.0208 times x minus 0. Oh, we can't type in x. Actually, we have to write the multiplication sign, bracket, x is this value over here, minus 0. The times sign is necessary. And that was 192, I believe. Okay, so we press enter, and I'll drag that down. Okay, so these are the points on the quadratic model, and you can see some are very close and some are very far apart. We're going to get those differences over here. So let's call this column, I don't know, differences. So that's going to be, we can do subtracting, subtract this one from this one, or the other way around, doesn't matter. These are the differences. They're all negative at this point, so sometimes you get a mixture of positives and negatives. So we have to do the absolute value of these numbers to make them positive. So absolute differences. Okay, so that's going to be equals absolute values ABS, and I'll click on this one, press enter, then I'll drag down. So these are the differences between the points on the graph and the points on that I plotted on the actual thing, and the points on the quadratic. Okay, so then I'm going to find the average or the mean of these. Then I type in equals average, and I'll select all this data. Okay, so the average is 9.28. Okay, we call that the mean absolute difference, or mean absolute error. So now this number here, if you did a different model, you could calculate this mean and compare them. So if I did another model and I got a mean absolute error of 5, then the other model is better, right? And the best model will always be the one that you use on your calculator. If you do quadratic regression on your calculator, then what that does is it mathematically figures out the lowest possible absolute mean error.